Hi everyone, welcome to the Robotics for Everyone series. Well, today in this topic, we will cover something that might sound a bit technical at first, but trust me, by the end of this video, you will understand why this is particularly revolutionizing the robotics industry. Um, I'm talking about ROS2, which stands for Robot Operating System 2. Now, before you worry, this isn't going to be a coding tutorial. Instead, think of this more like your executive briefing on what ROS2 is, why it's important for you to know about it, and how it is really changing the way we build robots in the industry. So, whether you are a product manager evaluating robotic solutions, a business leader exploring automation, or just someone curious about how the modern robots work, this video is definitely going to help you. So, what is ROS2? Let's start with a bit of a twist. Despite its name, ROS2 is not actually an operating system like our Windows, our Mac OS, our Linux. I know this is confusing, right? But think of it more like this, that if your robot were a restaurant, the operating system like the Linux or your Windows would be the building itself, the foundation walls, the infrastructure, and everything associated. ROS2 would be the kitchen management system. It doesn't replace the building, but it organizes how all the chefs, the waiters, and the managers communicate and work together. So, in the technical terms, ROS2 is what we call as the middleware. It sits between your robot's operating system and the actual application software that makes your robot do things. ROS2 is a collection of software tools, libraries, and the messaging systems that help the developers build robot applications. So here's what makes it really special is that it breaks down the complex robot software into manageable pieces which are called as nodes, and think of these as like specialized team members, each with a specific job. It provides a standard way for these nodes also to talk to each other like a universal language for robot parts. It includes ready-made tools for common robotic tasks like navigation, vision processing, and sensor data handling. It comes with the debugging and the simulation tools, so you can test your robot before building the physical hardware. um, Imagine you are building a self-driving delivery robot. You need cameras to see, sensors to avoid obstacles, and then motors to move, as well as software to plan the routes. So ROS2 really provides the framework that lets all these components work together seamlessly, even if they were built by different teams or companies. To understand why ROS2 is such a big deal, let's just quickly go back to 2007. Two Stanford PhD students noticed that everybody in robotics was reinventing the wheel, building the same functionality over and over. What was their solution? They came up with an open source framework that everyone could use and improve. This became ROS, which was released in 2010, and it quickly became the industry standard. But as ROS grew into commercial products, limitations started appearing, and in 2017, ROS 2 was released, which was a complete rewrite with the enterprise grade security, better reliability, without a central point of failure, real time performance for the industrial applications, and then support for multi robot systems. So, this really kept what developers loved, but it also helped add the professional features businesses needed. Let's go a little bit into the key concepts that exist in ROS2. Um, you will hear a lot of people mention this when they discuss about ROS2. Again, don't worry, I will try to explain this in as simple and plain English as I can. The first one is your nodes, which are your robots team members, right? So think of nodes as specialized workers on your robot. Each node has one job and it does it well. For example, in a delivery robot, one node reads the data from the camera, another node processes those images to detect obstacles, a third node controls the motors, and there could be another node that is planning the route. So why split things up this way, right? Because this just makes debugging easier. It allows teams to work in parallel and lets you reuse components across different robot projects. The second one is the communication channel, which is called as topics. Topics are how these nodes share information. So think of them like radio stations. Some nodes broadcast information and the others tune in to listen. So, for example, the camera node broadcasts images on a topic called as slash camera slash image. Any node that needs camera image subscribes to that topic, and then multiple nodes can listen to the same topic simultaneously. So this really is more like a publish subscribe model, which is incredibly flexible. So you can add new features by having new nodes subscribe to the existing topics without really changing the original code. A lot of developers and people on the technical side would really understand what is a publisher subscriber model really. The third one is services, which is more like a request response communication. So sometimes you don't want continuous broadcasting, right? You need to ask for something specific and get a response. That's what services do to this. So, again, like for an example, your robot needs to turn its camera, let's assume 45 degrees. You send one request to a camera control service, it turns the camera, and then it sends back confirmation with a new image. Think of topics as news broadcast, which is like one way and it's continuous. And think of services as a customer service desk, which is like two-way and then on demand. The fourth one in the list of the concepts that are used in ROS2 is actions. Actions are really long running tasks with feedback. So actions are for tasks that take time and where you want progress updates. So the example could be that if you were to navigate to, let's assume, the loading dock, this might take 2 minutes. So with actions, you send the goal, which is the destination. The robot sends feedback as it goes, assume 25% there, and then 50% there, and then 75% there. And finally, you get the result that it has arrived. So you can even cancel the action midway if the plan, let's assume, changes. So it has to go on as a task which keeps providing continuous feedback. The fifth is the parameters, which are more like your configuration settings. These are settings that you can adjust without rewriting the code. Say you have the same software but two different robots. One could be with larger wheels. So instead of changing the code, you just adjust a wheel radius parameter. Same software, different configurations. Now, this is huge for testing different settings using the same software on similar robots and allowing the operators to tune robot behavior in the field. The last one is the data distribution service, which is also known as DDS. So, here's what makes ROS2 really special. It uses data distribution service for communication. Now, why that matters for businesses is that there isn't any single point of failure. So nodes discover each other automatically. It has built-in security, so encryption and authentication really protect your data. There is quality of service, which means that the critical data gets priority even when the network is busy. And there is scalability, so the works great when like multiple robots or large systems come into play. So DDS is used specifically in military systems, the air traffic control, and financial trading. And thereby, it is a proven technology for mission critical applications. Let's talk what ROS2 is not also now. Um, Let me quickly clear up a few misconceptions. ROS2 is pure software. It doesn't come with motors, sensors, or robot parts. It's designed for the brain of the robot, running on computers for complex calculations. For low level hardware control, you often use, as you would probably know or not know, microcontrollers that communicate with the ROS2 system. And ROS2 is a framework, not a complete solution, that your team still needs to design the behavior, integrate the hardware, and write application specific code. It but it also provides the tools to do it. This which makes it faster than really starting from scratch. When should you really use ROS2 then? Right? So ROS2 is ideal when your robot has, let's assume, multiple sensors that need coordination. When you need autonomous navigation or complex decision making, when you are building a fleet of robots that have to coordinate, you want to leverage existing robotics packages that come. When your projects need flexible modular architecture, and you really need professional grade reliability and security. So that is pretty much on what I had to share about ROS2. If I were to just quickly wrap all of this up, ROS2 isn't really magic, and it's not the answer to every robotics challenge, but this is more like an industry standard framework that's enabling the current boom that we are seeing in the commercial robotics. So, from self driving cars to warehouse robots to the surgical assistants, ROS2 is really providing the software foundation that lets your teams focus on true innovation rather than just reinventing the basic infrastructure. um, for business leaders and product managers, program managers, understanding ROS2 really helps you make informed decisions about the robotics projects. They to help you evaluate, let's say, vendors and including like building the right teams. So when a robotics company tells you that they are using ROS2, you know what that really means and why it might be, a good sign. We all understand that the robotic evolution revolution is already here, and ROS2 is the software framework that is powering much of it. So whether you are building robots, you are investing in robotics companies, or you're just trying to understand this rapidly evolving field, um, I just hope that this video has demystified a little bit of what ROS2 is and why it really matters. So thank you so much for watching this. If you found this really helpful, please like and subscribe. Also, drop in a comment if you have any questions or you want me to dive deeper into any specific aspects of this topic or in general about robotics. Again, this series has been started to demystify a lot of what robotics today is all about. And I'm looking forward to some more suggestions, ideas on what more topics can we bring to this community. So, until next time, keep exploring the amazing world of robotics, and I will see you in the next video.